Hello, welcome to Notes 8.6, Radians and Trigonometric Functions. So we're going to start off by practicing converting from degrees to radians and radians to degrees. So remember that the conversion is 180 degrees is pi radians. So if you want to go from radians to degrees, you multiply by 180 over pi. So again, you saw this example in the last notes. So the pi's reduce, the zeros reduce, so it's 7 times 18 is 126. If you want to go to degrees to radians, then you do opposite. So multiply by pi over 180. So when you do that, the zeros reduce and you get 25 pi over 18. So when you're doing this, a lot of times it might be handy to have a little four-function calculator to make your calculations a little quicker. But it's not too bad. Okay, so we're going to convert to degrees to radians or radians to degrees. Depending on whatever you start with, you're going to go opposite. So I'm in radians. How do I know? Because of the pi. So to convert, I'm going to get rid of the pi. So I need it in the denominator. So 180 over pi. So for those of you that remember chemistry, this is like your unit conversions. So if pi is in the numerator and you want to get rid of it, you need it in the denominator. So by doing that, right, the pi's reduce. So I have 6 times 180 divided by 5. So 6 times 180, right, is 1080 divided by 5. You get 216 degrees. All right, so 216. There we go. Right, theta equals 140. So now you're in degrees. So I want pi, so I'm going to put it in the numerator, so it's pi over 180. So here the zeros reduce, so you get 14 pi over 18. Both of those numbers are divisible by 2, so this would be 7 pi over 9, right? Divide by 2. Wait, 16 pi over 9. I'm in radians because of the pi, so I need it in the denominator to get rid of it, so 180. So the pi's reduce, so you have 16 times 180 divided by 9. So this ends up giving you 320 degrees. All right, negative 120, negative doesn't really have any bearing. I'm in degrees, so I want pi, so I'm going to put it in the numerator and put 180. Then I can reduce some, right? The zeros reduce. So negative 12 pi over 18. They're both divisible by 6. 6 goes into 12 2 times. And into 18 3 times. So it's negative 2 pi over 3. Okay, I want to get rid of the pi. So I put it in the denominator. 180 on top. So the pi's reduce. So it's negative 5 times 180 divided by 3. So you end up getting negative 300. Right, negative 5 pi. So I want to get rid of pi. So put in the denominator, put 180 on top. The pi's reduce. So negative 5 times 180. So this is negative 900. So not too bad. Understanding again the conversion 180 equals pi radians. So you're using 180 over pi or pi over 180. Right? That's the conversion. So 2, sketch the reference angle and then find sine, cosine, and tangent. Okay, so 2 pi over 3. So again, remember from the last lesson, I'm going to rewrite pi in terms of my denominator. So this is 3 pi over 3. If you went all the way around, you'd be at 6 pi over 3. So 2 pi over 3 doesn't make it quite to 180. It's in quadrant 2. Okay. So my theta prime is pi over 3. So I have this triangle here, right? Pi over 3 is what in degrees? It's 1/3 of pi. Well, what is pi? Pi is 180. So what's 1/3 of 180? 60 degrees. So this is 60. So remember your special right triangles. If that's 60, this would be root 3, this would be 1, this would be 2. So sine of theta is going to equal opposite, so root 3 over hypotenuse. Cosine theta is adjacent, 1 over hypotenuse, and tangent of theta is opposite over adjacent. Now, we've got to be careful because we're in quadrant 2. And remember, all students text in class, so in quadrant 2, only signs should be positive. These should be negative. And why are they negative? Because if you draw that triangle, you went left 1. So if you have this triangle right here, which we basically just kind of enlarged, right, to make it easier to see, you went left 1, so it's negative. That's why those two fractions are negative. So same thing we did earlier in the unit, it's just now we're working in radians to begin with. Okay, 7 pi over 4. So first off, I'm going to rewrite pi in terms of my 4. So 4 pi over 4, 8 pi over 4. So I make it all the way in to quadrant 4. Okay, so again, you can draw your triangle. Right, my theta prime is pi over 4. Right? Because this distance here is pi over 4. So that is 45 degrees because pi is 180. 1/4 of that is 45. So this is 45 degrees. So this would be 1 root 2. So sine of theta is opposite over hypotenuse. 1 over root 2, but you're never going to write that. You'd write root 2 over 2. Right? We learned that earlier in the unit. Cosine theta, adjacent over hypotenuse. So 1 over root 2, which we write as root 2 over 2. And then tangent of theta, opposite over adjacent, so it's 1. But again, we're in quadrant 4. Only cosine should be positive, so these should be negative. And why are they negative? Because this is a -1 because you're going down. Now back here, some of you might be wondering, well, how did I get pi over 3? Because this is 2 pi over 3. How far is that from 2 pi to 3 pi? It's just 1 pi over 3. Right? How did I get pi over 4? This is 7 pi over 4. So the distance I'm coloring in red right now. Right? How far is it from 7 pi to 8 pi? It's 1 pi over 4. And remember, I told you, your reference angles are going to start becoming pi over 4, pi over 3, pi over 6. Right? Because we're using those special right triangles in the 30, 60, and 45 degrees. That hasn't changed the entire unit. Wait, example 3. Right? Find sine, cosine, tangent. Sketch the reference angle in the correct quadrant. So -4 pi over 3. This would be -3 pi. This would be -6 pi. Okay, so I for sure make it here. Now this is where we got to be careful, right? -4 pi is not going to go past quadrant 2. Okay, so, right, just remember we're going to need this, all students text in class. Okay, so I know that sine's going to be positive, so I just got to figure out, okay, which triangle am I using? Because we're going to figure out sine of theta, cosine theta, and tangent theta. And I know since I'm in quadrant 2, sine will be positive, the other two are going to be negative. So what's my reference angle? Well, this is negative 4 pi over 3. So how far is it? What is this color? I'm coloring green. What is that angle? So theta prime is pi over 3. Right? Pi over 3 is 1/3 of pi. Pi is 180 degrees, so it's 1/3 of that. 60 degrees. So this is 60. So this would be root 3. This would be 2. This would be 1. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. So 1 over 2. Tangent is opposite over adjacent. And again, why are these two fractions negative? Because technically that triangle, when you drew it, you'd go left and then up. So left is negative. Remember, drawing left and drawing down are negative. But you don't really need to remember that as long as you remember the fact that all students text in class. That will always give you the signs. Okay, negative 5 pi over 6. So this would be negative 6 pi over 6. This would be negative 12 pi if you went all the way around once. So I don't make it quite to 180 degrees. So I'm in quadrant 3. Well, I know that all students text in class, so only tangent's going to be positive. So we're going to do sine of theta, cosine of theta. Both of those are going to be negative. Tangent of theta is going to be positive. So I have my triangle, right? This is where I am at. So I need to know what's my reference angle. Well, this is negative 5 pi. So theta prime would be from negative 5 to 6 is 1 pi over 6. And pi over 6, right, is 1/6 of pi. Pi is 180 degrees. So what's 1/6 of 180? 30 degrees. So this would be 1, root 3, and 2. So opposite hypotenuse. All right, and we know this is negative. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent, but we won't write 1 over root 3. That's root 3 over 3. So again, right, I got to figure out which quadrant to then figure out whether my sine, cosine, tangent are positive or negative. Right? I can use the fact that all students text in class to help with that. Then I need to know, well, what's my reference angle? Is it 30 degrees, 60 degrees, 45? Okay, negative 8 pi. So this would be negative pi. This would be negative 2 pi. So if you go all the way around, that's negative 2, negative 4, negative 6, negative 8. Right? So I'm over there at 2 pi. Okay, so there is no triangle. I can't draw a triangle. But remember, we still know, right, on the unit circle, we know that radius is 1. Right? I'm at the ordered pair. 0, sorry, not 0, 1, 1, 0. Right? We're on the quadrantal. Right? So we have to use the x, y, and r again. So sine of theta, right, would be y over r. So r is 1, y is 0, so you get 0. So, cosine of theta is x over r. X is 1, r is 1, 1 over 1 is 1. Tangent of theta is y over x, so 0 over 1, which is 0. So you can still end up on the quadrantals in radians and degrees. So you just got to always keep in mind, when you're inside the quadrantals, you can always use opposite, adjacent, hypotenuse because you can draw the triangle. But when you're on the quadrantals, there's no triangle to draw. So you got to remember sine, cosine, tangent in terms of x, y, and r. because it does happen every once in a while when you end up on those quadrantals. So again, as I'm doing this, first thing, well, what quadrant am I in? Okay, sine, cosine, tangent, are they positive or negative? Well, I know that all students text in class, so that can help me with that. Then, what's my reference angle? Figure that out in radians, convert it to degrees real quick so I know which of the three triangles to look at, and that helps me find sine, cosine, and tangent. So make sure you answer the essential question, 3 to 5 sentence summary. Once you've done that, you're done with your notes. Have a wonderful day.